Let us discuss first what is all about the higher order derivatives. The idea is that for a given function, say y is equal to f of x, then the derivative of that function is said to be as derivative of y with respect to x, or simply y prime. Now, if the derivative of that first derivative can be differentiated, therefore, the derivative of that first derivative is said to be as the second derivative of the function with respect to x, or simply as second derivative of y with respect to x, or y double prime. And then again, if the second derivative can be differentiated, then the derivative of that second derivative is said to be the third order derivative of the function with respect to x, or y triple prime, and so on. So we call this as the higher order derivatives. We have this notation that this is only for the function y equal to f of x. So we have the first derivative as derivative of y with respect to x, or y prime, or f prime of x. Now for the second derivative, this is now expressed as second derivative of y with respect to x, or y double prime, or f double prime of x, and so on. Therefore, for the nth derivative, this is nth order derivative of y with respect to x, or y raised to n, f raised to n of x, and so on. Now, these symbols are called the Leibniz notations. Let us try the first example here. Y is equal to negative 6x to the fifth plus 5x to the fourth minus 2x cubed plus 3x squared plus 10x minus 5. And then we are looking for the sixth order derivative here. So then we have to start with the first order derivative. So y prime, this is by means of power, bring down 5 times negative 6 is negative 30, less 1 from exponent, so this is x to the fourth. Next term, bring down 4 times 5 is 20, less 1 from the exponent, so this is cube. Next term, bring down 3 times negative 2 is negative 6, now less 1 from the exponent, so this is 2. And the next term, bring down 2 times 3 is 6, less 1 from the exponent, so this is x. And 10, and derivative of x is 1, and negative 5 is 0. Then we can now differentiate the first derivative, and this is our second order derivative. This is by means of power again. So bring down 4 times negative 30 is negative 120, less 1 from the exponent, so this is now x cubed. And then the 3, bring down 3 times 20 is 60, and less 1 from the exponent, so this is square. And then next is bring down 2 times negative 6 is negative 12, and less 1 from the exponent, this is raised to 1. And then 6 times derivative of x is 1, and derivative of 10 is 0. Then, as you can see here, we can now differentiate the second order derivative. Then, therefore, the derivative of the second order is the third order, or y triple prime. By means of power again, bring down 3 times negative 120 is negative 360, less 1 from exponent, so this is x squared. Bring down 2 times 60 is 120, less 1 from exponent, so this is x. And derivative of negative 12x is negative 12. Derivative of 6 is 0 for the constant. Therefore, we can differentiate the third order. Therefore, this is now the fourth order derivative. So this is by means of power. Bring down 2 times negative 360 is negative 720. Less 1 from exponent, so this is x. And derivative of 120x is now 120. Derivative of negative 12 is 0. So we can differentiate again the y fourth order derivative, and this is now the fifth order derivative. So negative 720x is now negative 720. Derivative of 120 is 0. Then we can say that our sixth order derivative is 0 because derivative of constant is 0. For our next example, y is equal to cube root of quantity 1 minus 2x raised to the fifth power, and then we are looking for the second order derivative. Now, this function can also be expressed as the quantity 1 minus 2x raised to 5 over 3. And then we can apply the power rule here. This is an example of derivative of u raised to n, wherein we have to bring down the exponent and then the quantity raised to n minus 1 and multiplied by the du. So might as well as we have to find the derivative of u. So our u here is the quantity 1 minus 2x. Then the derivative of this is negative 2. Therefore, as the first derivative y prime, by power rule, bring down the 5 over 3 exponent and then the quantity raised to 5 over 3 minus 1 is 2/3 multiplied by the du as negative 2. So we can simplify the first order derivative y prime as negative 10 over 3 because we have to multiply the negative 2 by 5. And then the quantity 1 minus 2x raised to 2/3. Then we can find now the second derivative as y double prime. We have the negative 10 over 3 to be multiplied by bring down the power again, which is 2/3. And then the quantity 1 minus 2x raised to 2/3 minus 1 is negative 1/3. And then multiplied by the du, which is negative 2. Then our answer now is negative 2 times 10 is negative 40.